Assalamualaikum and hi everyone. So today we are going to cover the last topic in our syllabus, which is topic 8 on lists. In this topic, we are going to look into the introduction to lists and its operation, and then the list implementations in array and also linked list. So in array implementation of list, we are going to look into ArrayList and vector classes, and in linked list, we are going to look at linked list example. We are also going to look at the list processing, which is the traversal. What is a list? A list provides a way to organize data. For example, we can have a to-do list. So we have the first one, what we need to do, the second one, third one, and so on. A list is a popular data structure to store data in sequential order. For example, a list of students, a list of available rooms, a list of cities, and a list of books can be stored using lists. Similar to what we have learned in array, in list we need to know what is the element and what is the index number. For example, in this linear list L, we have E0, E1, E2, E3, and En-1. So the relationships E0 is the zeroth or the front element. En-1 is the last element. This slide shows the example applications of lists. So we have students in F22A02. So we have these different names of students. And then maybe for questions in exams, we have question 1, question 2, question 3, and question 4. Or we can also have days of the week. And it will list out Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So in short, lists can be anything. List operations. These are some of the useful set of operations. Currently, we are looking at it in general. We haven't looked into ArrayList, vector, and also linked list. So this set of operations are add an element at a specific index, remove and return element with given index, determine list size, get element with given index, and also determine the index of an element. The methods that we are going to use later on are called add, remove, size, get, and also index of. Assume that our list is called L. It has A, B, C, D, E, F, G. If we want to add an element at a specific index, then we can do it by writing add 0 h. That means that we want to add h at index 0. So our list L will change to have h at the beginning. So instead of A, B, C, D, E, F, G, it will have h, A, B, C, D, E, F, G. The index number of A, B, C, D, E, F, and G has been increased by 1. What happens if we write add 2h? So that means that we want to add h at index number 2. If we look at our initial list where we have A, B, C, D, E, F, G, at index 2 is the letter C. So C now it has the index number 3. In the modified list, it will have A, B, H, C, D, E, F, G. The index number of C, D, E, F, G are increased by 1. What happens if you try and write add 10h? It will give you an error. And the error that you will get is called the index out of bound exception. This is because index 10 does not exist. Currently, we have values at index 0, which is A, 1, B, at index 2 is C, index 3 is D, index 4 is E, index 5 is F, and index 6 is G. So, if we write add 7h, that will not give us an error because at index 7, that is after the letter G. But if we try to do at 8H, it will still give us an error because there's no index number 7. G is at index number 6. So we have to have some values at index number 7 first, then only we can add something to index number 8, or in this case at index number 10. That means that you cannot jump off to any values, but you have to have values at each of the index. You also cannot have a negative value. For example, at -6H. This will also give you an error. If we want to add a new entry at the end, we can write it as at H, for example, if we want to add the letter H. So the letter H will be added at the end of the entry. We do not need to specify the index. But if we write at 7H, that is the same as when we write at H, because H will be added at the end after the letter G. To remove an element, we can write it as remove 2, for example. So this means that we want to remove at index number 2, which is the letter C. So our list L will become A, B, D, E, F, G, because C has been removed. The index of D, E, F, and G are decreased by 1. So that means that the index number for D is no longer 3, but it has become 2. Similar as before, we cannot have a negative index number. So if we try and do remove -1, it will give us an error. Or if we try to do remove 20, which is more than what we have, it will also give us an error. To get the size, we can write it as L.size. It will give us 5. This is because we have the index number from 0 to 4, and when we include the 0, that becomes 5. So that's why the size is 5. Similar as what we have learned in array before, we don't have any values at index number 5 because the maximum number of index that we have is at 4. We can get the element with any given index. For example, if we write get 0, it will display the letter A. If we write get 2, it will display the letter C. Get 4 refers to E. And similar as before, if we use negative number or any number that exceeds our index number, it will give us an error. For example, writing get -1 or get 9. To find the index of the list element, we can write index of, for example, the letter D. It will give us the index number, which is 2. If say that we want to find out what is the index number of the letter A, we can write index of A and it will give us 0. Even though in our list we have A, B, D, B, A, but when we do index of A, it will detect the first A that it finds in the list. That's why it gives out 0, not 4. If we try to find the index of an element that does not exist, it will give us -1. -1 is invalid index when the element does not exist. When we write index of Z, it does not give us an error. It will always print out -1. This slide shows the use of add at a certain index number and also remove operations on an initially empty list. At the first part, when we write mylist.addA, we are adding the letter A. And then the next one is mylist.addB, because we did not write at which index number, it will add at the end. So that's why in the list we have A, B. So the same when we try to add C, it will be added at the end. Say that we write mylist.add at index 1 the letter D, so it will place D at index 1. So we would have ADBC. So B was previously at index 1. Now it becomes index 2. Similarly, if we write mylist.add 0E, E will be added at index 0 and ADBC index number will be added by 1. If we write mylist.remove2, we are removing whatever value at index number 2. So before we have EADBC, so index number 2 would be the letter D. So when we run this code, it will give the output EABC because D has been removed. List is one of the interfaces specified in the Java collection framework. The JCF provides several types of collections such as sets, lists, queues, and maps in the form of interfaces. A collection is a container object that represents a group of objects, often referred to as elements. This figure shows the Java collection framework hierarchy. You can refer to the Java API for the whole hierarchy. From here, you can see that set and list are sub-interfaces of collection. In the concrete classes, we have vector, ArrayList, and also LinkedList. The collection interface is the root interface for manipulating a collection of objects. If you look at the operations, we have seen add, remove, and also size. You can refer to the Java API for all the methods that contain inside the collection interface. List is the sub-interface of collection. It has the add method, get, index of, and also the remove that we have seen earlier. In the list interface, apart from the methods specified in the collection interface, it also contains some methods such as boolean add, which is inherited, remove, int size, get, int index of, and also int last index of. You can refer to the Java API to know more about this. Several concrete classes implement the list interface, such as ArrayList, Vector, and LinkedList. They can be categorized based on the type of data structures used to implement the list. So array would be the ArrayList and Vector. Sequence of linked data or linked nodes would be LinkedList. What are the differences between ArrayList, Vector, and LinkedList? So ArrayList and Vector, the size of the array is fixed, but it allows dynamic expansion, meaning that if the capacity of the array is exceeded, then it will expand. The elements in ArrayList and Vector can be accessed directly using get and set. The main difference of ArrayList and Vector is, in Vector, it is synchronized. Array-based list is implemented using array. The size of the array is fixed, therefore dynamic expansion must be possible if the capacity of array is exceeded. This is a costly operation. Inserts and deletes require moving the elements. This is also a costly operation, except if the item is added or deleted at the end of the list. For example, add at a certain index, whatever value it is, or add all, or using remove x are inefficient. In ArrayList, each element can be directly accessed. For example, using the get and set method. What does it mean by dynamic array expansion? An array has a fixed size. If you refer to the ArrayList API, you will see that it stated there that the initial capacity of the ArrayList is 10. When the array becomes full, it will move all of its content to a larger array. So it will create a new array that is twice the current size, and copy all the data from the original to the new location. The new array now becomes the current array. This figure shows that the dynamic expansion of an array copies the array's content to a larger second array. This is why it says that this is a costly operation when the capacity of the array is exceeded. To create an ArrayList object, we would write ArrayList, the element type, and whatever we want to call it, equal new ArrayList, the element type, and close the brackets. For example, if we want to create an ArrayList of integers, the element type would be integer with capital I. So we would write ArrayList integer numList equal new ArrayList integer. If the element type, if we want to create an array of string, then the element type would be of type string. The element type can also be any classes that you want to create the object of. For example, we have ArrayList student, students equal to new ArrayList student. So that refers to the class name student. In ArrayList, we can use the add method. Add X method adds new item X at the end of the list. So it will increment the size of the list by 1. If we write add index X method, it adds the new item X in the mid list at whatever position the index value is. It requires shifting ahead from last element until element at index. It will assign X at the index that we wrote, and it will increment the size of the list by 1. Adding items in mid list. For example, the method that we use is add, and then we have our index. For example, here is 2, and the value that we want to add at index number 2 is Carla. Initially, in our list, we have Alice, Bob, Dog, and Haley. So now we want to add Carla at dog position, which is at index number 2. Before Carla can be added at index number 2, Haley, which is at index number 3, have to be shifted to index number 4. Then, Dog has to be shifted to index number 3. They need to make room to insert Carla as the third entry in an array. So now Carla is at index number 2. On your online learning, I have shared this code that is called ArrayList1.java. So in this code, you can see that I have created the array list of type string, and I have added Alice, Bob, Doug, and Haley. And then I would add Carla at index number 2. So you can try and run this code and print out what would be the output of it once you have used add Carla at index number 2. Now we will look at the remove method. It must shift existing entries to avoid gap in the array, except when removing the last entry. In all cases, it will decrease the size by 1. The method must also handle error situations such as when the position specified in the remove is invalid, or when the remove is called and the list is empty, and also any invalid call that returns null value. This figure shows what happens when we try to remove a list entry. For example, we are removing Bob, or we can write it as remove 1, which 1 refers to the index number. You can try it out to see if you write Bob or if you write 1, does it change the same thing? When this method is used, Bob is removed. Then Carla, Doug, and Haley will be shifted to the left by 1. So the size of the array has been decreased by 1. Just to be clear, once we have removed Bob from this list, the size of it becomes 4. However, the capacity of the array is still 10. you can run the codes for the add and remove methods that I have provided on your online learning. Using the ArrayList class, once the ArrayList object is created, you can invoke all the operations by calling the related methods. For example, we have create an ArrayList of type integer called numList. So we have written ArrayList integer numList equal new ArrayList integer. So we can use the add method to add some value to our ArrayList. For example, we can write numList.add 10. So that will add the value 10 at index number 0. Then we can add another number. So we can write numList.add 12. So 12 will be added at index number 1. Then we would write numList.set at index number 1 the value 11. What do you think would happen? What would be the output of it? If you run this code, you will see that the output that you will get is the number 10 and 11. This is because when you use the set method, it will replace the element at the specified position in the list with the new specified element. So in this case, we are replacing the number 12 with the number 11. If instead of using set method, if we use add, for example, as what I have written here, we have a.add 10, a.add 12, and a.add at index 1 the number 11, what do you think the output of this? Is it going to have the same output as what we saw when we used the set method? If you run this code, you will see that the output would be 10, 11, and 12. This is because in the beginning, 12 is at index 1. When we use a.add at index 1 element 11, it will replace at index 1 the value 11 and 12 will be at the index 2. It does not remove the value 2, but instead it will just shift it to index plus 1. Please refer to the Java API to know more about all the methods that are available. The vector class. Vector is the same as ArrayList, except that vector contains the synchronized methods for accessing and modifying the vector. None of the new collection data structures introduced so far are synchronized. If you don't need synchronization, use ArrayList since it works faster than vector. What does it mean by synchronized? It means that if one thread is working on the vector, no other thread can get hold of it. So it only allows one to be accessed at a time. Some of the methods in the vector class include add element, capacity, element add, and many more. You can refer to the Java API for the whole list. Vector also has the add method that we have been using so far. To use the vector class, we would write vector equal to new vector. So you can call it whatever that you want. To find out what is the capacity of the vector, we can write vector.capacity. To get the size of our vector, we can use vector.size. This will give us the capacity of 10 and size of 0 because we haven't added any elements yet. So we can add the elements by writing vector.addElement1. So we are adding the value 1 to index 0, and then we add element 2 to index 1 and element 3 to index 2. Then in the next line, we have vector.insertElement at 4, 1. So over here, 4 refers to the value that we want to add, and 1 refers to the index number. So we want to add the value 4 at index 1. What do you think the output would be? So currently, what we have is at index 0 is 1, at index 1 the value 2, and at index 2 the value 3. So when we have insert element at index 1 the value 4, then it will shift the value of 2 to index number 2. So we would have 1, 4, 2, and 3. Since we have all the elements, if we print out the size of the vector, it will give us the size of 4. However, the capacity will still be 10 because we haven't exceeded the maximum value of 10. Say that we have this code. Similar as before we add the elements, the vector capacity will give us the value 10 and the size of the vector is 0. I have written the for loop so that it will add the elements at index 0 up until index 11. So after adding all the elements, the capacity, because it exceeded the value 10 from before, it is now have the capacity of 20, and the size of the vector is 12 because it is the value from 0 to 11. Try and run this code to make sure that you understand how vector works and also how to get the value of the capacity and also the size. You should also know how to add the elements by using the add element methods. On online learning, I have shared another code which is in the file called vector1. Try and run those code to see what would be the output of it. Inside the codes, I have used add element method, add method, and also insert element add method as well. You should go through each line of the codes to make sure that you understand it. Link-based list is implemented using LinkedList. A linked list consists of a chain or sequence of nodes. Each node is an object that contains two attributes, which are the element that store the element and also next that store the reference to its next neighbor. The value of it is null if this is the last node in the sequence. Pros and cons of using linked list. The chain or list can grow as large as necessary. It can add and remove nodes without shifting the existing entries, but it must traverse a chain to determine where to make addition or deletion. Retrieving an entry requires traversal. Any entry in an array can be directly accessed. This figure shows a chain of nodes. The first one is just prior by adding a node at the end, and the second one is just after adding a node at the end. By using the method add index x, we can add item in the mid list. The figures show how it is being added in the chain of nodes using linked list. To remove a node, the method remove is used. From this figure, we can see that when we remove the node, we don't have to shift the existing entries. Similarly, we would use the remove method to remove the interior node. To create a linked list object, we would write it as linked list, element type, and the name of it equal new linked list and the element type and the brackets. For example, if the element type is integer, we would write linked list integer num list equal new linked list integer. This is similar to what we have done with ArrayList. It's only that for this one we are using linked list instead of ArrayList. List processing, list traversal. Iterator enables us to iterate over or traverse a collection. Iterator is an interface in java.util. It contains only 3 methods, which are hasNext, next, and remove. To get the iterator object, call the iterator method that will return an implementation of these methods. In the iterator approach, we will write iterator and call it whatever you want equal list.iterator, and then using the while loop, while it.hasNext, then we will print out the value of it.next. For example, in the code on your online learning, which is in the ArrayList1 file, I have written the iterator approach, where I wrote iterator it equal to name.iterator. This names refers to the array list type string, and I call it as name, where I added Alice, Bob, Dog, and Haley onto that array list. Inside the while loop, when it checks that my array has the hashnext value, then it will keep on looping until the end of the array. You can also use the enhanced for loop without using an iterator. So you can write it by writing for and then the object element and then the list. In the ArrayList1 file, I have also added the enhanced for loop. If you see over here, the object O is the single item from the collection and name is the variable to loop through. I called my array list as name. So in the for loop, I would write for object O name and do my system.out.println. This will give me the same result and the same output as if I am using the iterator. Other than iterator and enhanced for loop, you can always use the normal for loop or while loop. It will display the same result. List traversal with ArrayList. This example creates an array list with specified capacity and inserts elements into the specified location and remove an element in the list. Finally, the example traverses the list using the iterator. So let's look at this example. So we have array list type integer and we call it as A list. We then add the value 1 at index 0, add the value 2 at index 1, and then we add the value 3 at index 2, and then we add the value 1 at index 3. So our current value is 1231. The next line is we have alist.add at index 0 the value 10. So our A list becomes 10, 1, 2, 3, 1. Next, we have alist.add 330. So we are adding the value 30 at index number 3. So now in our A list, we have 10, 1, 2, 30, 3, and 1. In the next line, we have alist.remove 1. So what does this 1 refers to? Does it refer to the value 1 or whatever value at index number 1? If you run at that point, it will print out 10, 2, 30, 3, and 1. So that remove 1, that refers to the index. You can try this code by changing the remove 1 to maybe remove 3. Then you can see that it will remove the value 30, which is at index number 3. The next line is alist.set 340. So we are setting the value 40 at index number 3. When we are using the set method, it will remove whatever value that is at that index number. It does not shift it, but replace it. To print out the list, we can use the iterator. So we will write iterator list equal to alist.iterator. While the list has next, then it will print out whatever the next value is inside our array list. So the output would be 10, 2, 30, 40, and 1. You should try and run the code to make sure that you understand all the codes and also how to get the output that it shows you. List traversal with linked list. This example creates a linked list and inserts and removes elements from the list. Finally, the example traverses the list forward using the list iterator. We would first create the linked list object. For example, over here, we would create of type string. So we have linked list string list equal new linked list string. Then we add the value red to the list. The next line, we add the value green at index number 0. So now we have green and red. Then we add blue. So blue would be at the end of it. So we have green, red, and blue. In the next line, we have add yellow at index number 1. So now we have green, yellow, red, and blue. In the next line, we have list.remove list.size -1. So currently, what do you think the size of this list? So we know that we have index up until number 3 because index 0 is green, index 1 is yellow, index 2 is red, and index 3 is blue. So the size of it would be 4 because that includes the value 0. When it asks for size -1, so that means that the value of 3, so in the list.remove 3, it will remove whatever value at index number 3, which is the value blue. To go through our list, in this example, we use the iterator. So we have our while loop and we use the hasNext method. And inside our while loop, we have our system.out.println list.next. The output that we will get is green, yellow, and red. That's all about this topic on lists. So we have looked at ArrayList, vector, and also LinkedList. We have also looked at different methods available, such as the add method, remove method, and also the set method. We also have looked at Traversal, where we are using the iterator to go through our list. We have also looked at enhanced for loop and also using the normal for loop and while loop. On online learning, I have posted some MCQ questions and also past year exam questions. Try and answer those questions, and we will discuss it in the next class. That's all. Thank you.